Hi grade 12s and welcome to this video. In this video we're going to be going through the Gauteng June 2022 Maths Paper 1. Okay, so question 1 we have x squared is equal to negative 4x. Okay, I know that when you see an equation like this, it can be tempting to just go ahead and divide both sides by x. Now, the reason you shouldn't do this is because we are solving for x right now. So we don't know what x is. X could be equal to 0, and if you divided both sides by 0, then your equation is going to be undefined, because if you divide anything by 0, your answer is undefined. And so that's why you should avoid dividing both sides by 0. So what we can do is, or dividing both sides by x, what we can do is just look that we have x squared on this side. Since this is already positive, we can go ahead and take this over. So we have x squared plus 4x is equal to 0. Okay, we have two terms on this left hand side, and in both terms x is common, so we can take x out as a common factor, and then we're going to have, you can simply say x squared divided by x. That's going to give you x. That is what you need to multiply to x to get back to x squared. And then you can also say 4x divided by x, and then this positive 4 is equal to 0. Now, I want you to remember that this is exactly the same as having x plus 2 multiplied by maybe x plus 4 being equal to 0. And the same way we take these and we equate them both to 0 is exactly what we're going to do here. Now, why are we doing this over here? Remember, they're saying something multiplied by something is equal to 0. So, if you have something times something and gives you 0, it means that either one of them must have been 0 in order for you to get a 0, because anything multiplied by 0 would give you 0. The same way 0 multiplied by anything would have given you 0. So we're saying that either one of them is equal to 0 in order for you to multiply them and get a 0. That's why we're going to go ahead and say here x is either equal to 0 or x plus 4 is equal to 0, since they're being multiplied. And so here x is equal to 0 or x is equal to negative 4. Okay, and then 1.1.2 we have x squared plus x minus 1 is equal to 0, and they say correct to 2 decimal places. Okay, so the minute they're already telling you that, you have to use the quadratic formula. So we're going to go ahead and just say x is equal to, and put the quadratic formula. Okay, and now we're just going to substitute. So we have minus b, and so whatever b is here. It's a positive 1, an invisible 1 that is here. So negative 1 plus minus the square root of that, our invisible 1 squared, minus 4. A is also a 1, positive 1. And then c is a negative 1, so negative 1, all over 2 multiplied by our positive 1 of a. Okay, so when I'm putting this into the calculator, I'm just going to start with the negative first. Okay, so this is what we get, and I only start with the negative 1 because it's a smaller factor. It's a smaller answer. So we get a negative 1,618, but remember we need to round off to 2 decimals, so that will be negative 1,62. So x is either equal to negative 1,62 or x is equal to, just go ahead and change that into a plus, and we get a 0,618, so that is 0,62. So x is equal to 0,62. And there are our solutions. Okay, moving on to 1.1.3, we have the square root of x plus 4 minus 4 over the square root of x minus 2 is equal to 0, and we have to solve for x. Okay, so this is an equation involving surds. In this equation, the first thing you should try to catch on to is, what are we trying to do? We're trying to solve for x. Since we're trying to solve for x, find what is stopping you from solving for x right now. So in this equation, I know there are surds, yes, that is actually stopping us from solving for x, but there's something that is a bigger problem. It's not really this surd that is that much of a problem. It's this one, because it's on the denominator. So we need to get rid of this first. And how we get rid of this, because this is being divided by square root of x minus 2, we can just multiply both sides by the square root of x minus 2 so we can get this out of the denominator. Okay, so we're just going to multiply both sides by the square root of x plus minus 2, sorry, not plus, minus 2, and then also multiply that by the square root of x minus 2. Okay, so let's see what we get now. So this, we have two terms inside this bracket, and so this one term is going to FOIL into these two terms inside the bracket. So we have an x square root of x minus 2 multiplied by square root of x plus 4. It's the same thing as having the square root of 2 multiplied by the square root of 4. When we have this, what we can do is, since they are both square roots, we can put them under the same square root, and we're saying 2 times 4. That's exactly what we're going to do in this case. So we're going to go ahead and just take this, and we're saying that it's the square root of these two terms being multiplied together. Remember, they're both binomials, they're two terms. So it's going to be an x minus 2 being multiplied by x plus 4. Okay. And then we have square root of x minus 2 being multiplied by negative 4 over square root of x minus 2. So since we have that, what is going to happen is that since we have a square root of x minus 2 on the denominator and the numerator of this number, they're going to cancel. Okay. And this is the reason they cancel. So if we didn't look at it like that, remember, you have a fraction being multiplied by something that is not a fraction. So you first have to make this a fraction so you can put it over 1. Since it's over 1, we are saying numerator times numerator, which is going to be negative 4 square root x minus 2 over 1 times that square root x minus 2. And so now you can see the top and the bottom would cancel. And that's why these two cancel. So we're just left with the negative 4. So it's just minus 4. And then is equal to, we have a 0 multiplied by square root of x minus 2, but 0 times anything just stays 0. Okay, so this is what we have. We have a surd, and we have a number. When you're solving for an equation that has a surd, you need to isolate the surd. So keep the surd on its own. So we're going to leave this here, x minus 2 and x plus 4, and we're going to take the 4 over the negative 4. So it becomes a positive 4. And then, now that we have this on this side, our next problem in solving this equation is our surd. So we need to get rid of the surd. So we can get rid of the surd by squaring both sides. And so the surd, the square root, and the square would cancel. And so you're just left with an x minus 2 being multiplied by x plus 4 is equal to 16. Okay, so we can go ahead and just FOIL this out. So we're going to have an x squared being multiplied by positive 4x, and then we have a negative 4x, and then we have a negative 8, and then we can just take 16 over and becomes a minus 16 is equal to 0. Okay, and then we're going to have x squared, then it is a positive 4x minus 2x, that just gives us positive 2x. Then negative 16 minus negative 8 minus 16, that is negative 24, is equal to 0. Okay, so now we just have to factorize this. So factorize this equated to 0. We have x times x. Then let's think about factors of 24 that can give us a 2 in the middle. So you can simply do this by just taking 24 and dividing it by numbers that you know can go into it. Another thing I just used to do is I can just press shift and the factorize button, but I don't think it's on. Oh, it is here. Okay, shift and fact. So you can see here we have 2 to the power of 3 and a 3. So that's like 8 and 3. Okay, so if you think about 8 and 3, they're not really going to give you a 2. If you say 8 minus 3, that gives you 5. Okay, so that doesn't mean that this is not going to work. That means you can just try, instead of saying 8, remember this is 2 to the power of 3. It's like 2 to the power of 3 times 3. We could also just share that. That means it's 2 times 2 times 2 times 3. So I could try maybe 2 times 2 being 4, and 2 times 3 being 6. I could try the factors 4 and 6. And that actually looks more promising to give you a 2 in the middle. So if you try 4 times 6, it will give you a 24. Okay, also remember that we have a negative 24. The only way you can get a negative number when you multiply two things is if one of them was negative. So where we have the 6 and this 4, it means only one of it was negative. So think about it. We have a positive 2x in the middle. So it must have mean that we had a positive 6 minus 4 to give us a 2, a positive 2. So those would be our factors. Okay, so x is either equal to a negative 6 or x is equal to positive 4. Okay, so here it would seem like we're done, but we're not really done yet, because the thing is with surds, you have to square both sides in order to get rid of the surd. But when you're squaring both sides, there's a consequence for that. It means now before, okay, the answers that we had, yes, we may get one of the answers could be correct, but then the thing is that there's an extra answer here that may not be correct. So you need to check to see which one is not going to work. So you can actually check using the original equation. This was the original equation, and we're just going to go ahead and substitute negative 6 into this. So we're going to have to substitute these values into the original equation, and it should give us 0. So let's try negative 6. So if we tried negative 6 plus 4 and then negative 6. So go ahead and just put that all into the calculator. It should give you a 0. If it doesn't, it's not your answer. Okay, so we're just saying the square root of negative 6 plus 4, and then make sure you just press the side button to come out of the square root, minus, and then we have a fraction, then we have 4 over the square root of negative 6 again, minus 2, and I can already see that that's not going to work out well, because that is going to be a negative number. That's negative 8, square root of negative 8, which is going to make this undefined. Here as well, you can see that we have a negative 6 plus 4. So 4 minus 6, that's going to be negative 2. So this is already making the equation undefined, but this calculator is set on a different setting. So it's calling it I, meaning it actually is solving for it, but then this is not a real number. That's the thing. So in this case, as you can see, we have undefined. X will not be equal to negative 6. So you get an extra mark for saying that one is not your answer and the other one is. So if you try 4, so if we tried 4 and put a 4 here and a 4 here, this is what we would get. We'd get 0. And so we can see that, okay, this one is really equal to 0. And so you can say, therefore, x is equal to 4 only. Okay, so that is 1.1.3. Usually they expect you to do this. You will see it in the marking allocations when it's like 5 marks. Usually that's what they want you to do at the end. Okay, next we have an inequality. Okay, so in 1.1.4 we have this inequality, and notice that this is negative. It has to be greater than 0. So we need to solve for x where this will be greater than 0. Okay, I'm not going to FOIL out because I'm going to use this as it is. What we can do is go ahead and just find our critical values. So our critical values, since they say this times that needs to give us something greater than 0, then I'm going to say that x plus 2 is either greater than 0 or negative 3x plus 1 is greater than 0. I'll just find the critical value. So here our critical value is negative 2. Okay, and then here our critical value, if you just take the 1 over, we'll get a negative 1, divide both sides by negative 3, and we're going to get x and a 1 over 3. Okay, so our critical value is just 1 over 3 and negative 2. Okay, since we have these values, what we can do is draw a number line. We're going to draw a number line. Okay, that's a weird number line. Okay. And then we're going to put down our critical values, which was negative 2 and a 1 over 3. Okay, then you have to think about a number that is smaller than negative 2. And the number smaller than negative 2 would be negative 3. And then a number bigger than negative 2, that would be a negative 1. Same thing we have to do for 1 over 3, a number smaller than 1 over 3. Remember, 1 over 3 is quite close to 0. It's like a 0,333 recurring. So a number smaller than 1 over 3, we could take 0. And then a number bigger than 1 over 3, we can take 1. Okay, so we can go ahead and try these. So what you're going to do is you're going to substitute these into your equation and then find out if it really gives us a value greater than 0. So let's try negative 3. So I'm going to take the equation as it is. I'm going to put two brackets. So we're going to have negative 3 plus 2 being multiplied by negative 3. And then in place of x, we'll also put in a negative 3. And then plus 1. Okay, so as you can see, it gives you a negative 10. So it's not working for negative 3 because negative 10 is not greater than 0. It's less than 0. So it's not working for numbers that go this way, that are less than negative 2. So let's try negative 1. Okay, so in place of x, I'm going to put in negative 1. Place of x, negative 1. And we get a 4. Okay, so negative 1 is working because 4 is greater than 0. So it means that our numbers are going this way, numbers that are greater than negative 1. Also, another thing I want you to notice is that this inequality says greater than 0, not greater or equal to 0. So in this case where we don't have or equal to, our circle is not going to be closed. It's just an open circle. So it's moving this direction. And so these are numbers that are greater than negative 2. Okay, so we're saying that x is greater than negative 2. Another easy way to see that is look at your arrow. Your arrow is going to look exactly the same as your inequality sign. It points in the exact same direction. Okay, so we can also do this for 1 over 3. We're going to go ahead and substitute. You can try 1, but it's probably not going to work. 0 will probably work because they're probably pointing towards each other. So you can go ahead, since this is a quadratic equation. Okay, so we can try, if we tried 0. So in place of x, I'm going to put in a 0. And we get a 2. And 2 is greater than 0. So it means that numbers going towards this side are working. So we have a open circle on 1 over 3 because they didn't say or equal to 0. And then the numbers are moving this way, values less than 1 over 3. So follow the arrow. Its x is less than 1 over 3. Okay, so now that we have that, okay, you can also try the 1. You will actually see that it probably will give you a negative number. So if you tried 1, see, we get a negative 6. So that is not greater than 0. Okay, so since we know this is our answer, these are our answers, okay? But I want you to see what's going on with the inequalities, the table. Do you see that these numbers are pointing towards each other? It means that they are talking about the same set of numbers, the same group of numbers. And so we can actually write this together. So only ever do this when you see the inequalities point towards each other. So we can write it as, therefore, we are putting x in the middle. And then you just put the smaller number on here, which is negative 2. And then the bigger number here, 1 over 3. And then let's just look at how the inequality sign was facing. It was saying that x was greater than negative 2. So when you look at x versus negative 2, your inequality needs to face the x. So we draw the inequality facing the x. And then when you look at x versus the 1 over 3, the inequality needs to face the 1 over 3. So there we go. And so those are our solutions. So x is greater than negative 2, but less than 1 over 3. Okay. Okay, so in 1.2, we have a simultaneous equation and we need to solve for x and y simultaneously. You have been given, this is clearly a linear equation because we do not have any squared or cubed or anything like that. So our linear equation, always call that as your equation 1. Then we have a quadratic equation here. We have y squared. Okay, it's actually not a quadratic equation of a parabola, but this is going to be our equation 2. Okay, so we have these two equations that we just need to solve for x and y. We can go ahead and we see that y is nicely sitting on its own. It doesn't have any coefficient like a 2 or 3 or anything. So we can make that the subject. So we're going to take y over, and so we have a y is equal to, then we just still have the 3 here, and then plus 2x. And so this is now our equation 3. Then we're going to go ahead and just substitute equation 3 into equation 2. And then in place of y, we're just going to put 3 plus 2x. Okay, so we have our equation 6x plus 4. And then we have y squared. So in place of that, we're just putting a 3 plus 2x all squared is equal to 3 plus, and we have 5x being multiplied by y again, so that is just 3 plus 2x. Okay, so let's go ahead and just simplify that. So we're going to have 6x plus, let me just make more space. Now we have, a squared here. Okay, so we need to expand that. So we're saying 4 multiplied by. Okay, so since we have a squared here, an easy way to multiply this out is simply just by saying we're going to take 3 and square it. So that will give you 9. And then you take 3 multiplied by 2x, and so that will give you a 6x. Then multiply that 6x by 2, and that will give you a positive 12x. Okay, and then lastly, you take the last term and square it, and that will be a plus 4x squared. Okay, so this is a simpler way to do this because it's going to double. Since we have a squared, you're going to end up adding the same number twice. Okay, so that's what we do is equal to, you can go ahead and do the long way, but this is also another quicker way to save time during your exam. Okay, and then we have a 3. We have a 3 and then plus 5 multiplied by 3, that is a 15x, and then 5x multiplied by 2x, that is going to be positive 10x squared. Okay, so let's just multiply out what we need to multiply out. So 6x, and then we have a 4 times 9, that's like 18 plus 18, 36, so plus 36, and then we have a 4 times 12, which is like 24 plus 24, 48, so plus 48x, and then a 4 times 4, which is positive 16x squared, and then is equal to 3 plus, and then we just have a 15x plus 10x squared. Okay, before taking anything over, it is best to just simplify your left and your right hand side. So whatever needs to be added, add that. So let's look through here. Let's look for any like terms. Okay, so we just have a 6x plus 48x. It's like taking a 2, that makes it 50, so 54x. Okay, and then we have a plus 16x squared plus 36 is equal to 3 plus 15x plus 10x squared. Okay, now we can take things over. Notice that we have a 16x squared, and here we have a 10x. So it's best to just take everything over to the left hand side, since the 16x is bigger than the 10x, just so that you can keep the x squared positive. So we're going to have 16x minus 10x, and that gives you a 6x squared. Okay, and then we have a 54 minus 15. Okay, I'm just going to calculate that. So we have a positive 39x, and then we have a 36 minus a 3, which is positive 33, is equal to 0. Okay, looking at all of these numbers, they look like they can all be divided by 3. So I'm going to divide both sides by 3. And so here 6 divided by 3, that is 2. So 2x squared. 39 divided by 3, let's just check that. 39 divided by 3 is, okay, 13. So positive 13x. And then 33 divided by 3, that is 11. Okay, plus 11 is equal to 0. Okay, so this is what we have now, and we just have to factorize this. So the method I use is called the cross method. And this is how it works. everything is positive right now, so it's not really going to be that difficult to work this one out. We have a 2x squared. So we're going to have to think about factors of 2x squared, or what multiplied by what would give you 2x squared. And that would really just be 2x multiplied by x. And then we have to think about the last term. So factors of the last term, what times what gives you 11? Well, that's just 11 times 1. But in this case, it would really depend on how you put it. So 11 times 1, okay? And remember, it's a positive 11. So the only way you can get a positive 11 is by saying positive 11 times positive 1, or negative 11 times negative 1. But how we know it's not negative is because the middle term is positive. So it's both positive. And so this is called the cross method because we're just going to cross multiply. So we're saying 2x multiplied by 1, which gives you a 2x. And then we're saying x multiplied by 11, which gives you a positive 11x. And that gives you a 13x. So as long as you get the middle term, then you know that these factors are correct. So we have a 2x plus 11 and an x plus 1 is equal to 0. Okay, so we have that now, and now we're just going to go ahead and solve for x. So 2x is either equal to 11, divide both sides by 2, and so x is equal to negative 11 over 2, or x is equal to, we're taking 1 over, so negative 1. Okay, so those are our solutions for x. We found x. Now that we solved for x, we need to solve for y. Okay, you can call this equation 4. And so the last step is to take equation 4 and substitute it into the equation of y, which is equation 3. So we're just substituting equation 4 into equation 3. Okay, so we're just saying y is equal to 3 plus 2x, 3 plus 2x. Y is equal to 3 plus 2, and then in place of x, I'm putting negative 11 over 2. Or we're saying that y is equal to 3 plus 2, and in place of x, we're putting negative 1. Okay, so just go ahead and punch that into the calculator. So we have negative 8, so negative 8, or if we substitute a negative 1 in place there, so negative 1, we get a 1. Okay, so y is equal to 1. So these are our solutions for x and y in our simultaneous equation. Okay, and now we are at the last question of question 1. Okay, so this question says, given that 9x squared minus 12px is equal to negative 4p squared, for which values of p will the equation have equal roots? Okay, let's put down this equation first. So 9x squared minus 12px is equal to negative 4p squared. And so we need to find out for which values of p, okay, will it have equal roots? Okay, so normally this type of question, you're usually used to them putting in a quadratic equation and then just saying something like is equal to k. And then they'll say for which values of k will the roots be equal, or something like that. But in this case, they're not really doing that. Okay, we're still going to go ahead and find what delta is going to be for this. Remember, they are asking for equal roots. For you to have equal roots, delta needs to be equal to 0. Okay, so that's what we know about this. And remember that delta is b squared minus 4ac, so that part of the quadratic equation. So b squared minus 4ac just needs to be equal to 0. Okay, so I'm going to just go ahead and put this in a standard form, or more standard form than what it is right now. So we're going to take 9x squared and then minus 12px, and then we're going to take that over, so positive 4p squared is equal to 0. Okay, so let's just establish what a, b, and c is going to be here. Remember, this is an equation that we are going to focus on x. We're going to focus on x because they're saying for which values of p will the equation be have equal roots. Okay, so let's just focus on what A, B, and C are. So here, whatever the coefficient of x squared is, that is A. So that is our 9, that's our A. And then whatever the coefficient of x is, that is B. So in that case, that will be a negative 12p. That is the coefficient of x, whatever is in front of x. And then C is the constant, so the only one that does not have x in it. And so that will be your 4p squared. Okay, so we can just go ahead and put that in. So b squared is going to be, since this is our b, the negative 12p, we are saying negative 12p all squared minus 4 multiplied by a, which is 9, and then multiplied by c, which is 4p squared, okay, is equal to 0. Okay, so let's just solve for this equation. So we have negative 12 squared, which is 144. And then p squared is just p squared. And then we have, okay, I see numbers. So let's just multiply these numbers. Negative 4 times 9 times 4. Okay, so if we just say negative 4 times 9 times 4, we get negative 144. Okay, so the numbers will give us negative 144. And then we had a p squared, see, times p squared, so p squared, and is equal to 0. Okay, we have the exact same term here. So 144p squared minus 144p squared is equal to 0. So 0 is equal to 0. That's what our equation is saying right now. Okay, so remember the question was, for which value of p will this have equal roots? So to understand this, an equation is like a statement. It's like, for example, I could say x plus 2 is equal to 5. So x plus 2 is equal to 5. It's a statement that is true, but for a specific x value. So x plus 2 really is equal to 5. That's if x is equal to 3. Then the statement is true. Okay, so that's what an equation is. When an equation is equal on both sides, meaning, okay, so to get to there, let me just explain something else. Let's say I said, okay, let's try x being equal to 1 instead in this equation. So if you said 1 plus 2 is equal to 5, that would not be true. 3 is not equal to 5. And that's because there's only one specific answer for x in this equation. You only have that x is equal to 3, and then that's it. There's nothing else. Because then the left-hand side and the right-hand side would not be equal if you tried anything else but 3. In this equation, notice the left-hand side and the right-hand side are equal. When this happens, it means that your answer will work regardless of whatever number you try. As long as it is a real number, it's going to work. So with this equation, if I tried 144 and then in place of p, let's say I just tried 1 squared minus 144, 1 squared, I would still get a 0. If I tried 144 times 4 all squared minus 144 times 4 all squared, as you can see, I'm subtracting the same thing by the same thing. I'm still going to get a 0. It means that p is going to work for every single number as long as it's real. So our answer for this, let me just erase all of this. Our answer for this is that p is an element of real numbers. It's just going to work for every single number. So you can say the equation will have equal roots for all real values of p. As long as it's a real number, it's going to work. Okay, so that concludes question 1, and I'll see you in the next part in question 2.